All right, guys, today we're going to talk about Chapter 3, Risk, Economics, and Environmental Concerns. We're going to talk about making decisions, characterizing risk, environmental economics, comparing economic and ecological systems, using economic tools to address environmental issues, and economics and sustainable development. Let's start with considering an example of drinking water, sanitation, and disease. The World Health Organization estimates about 1.7 billion cases of diarrheal disease occur each year and result in about 500,000 deaths of kids under the age of 5. The major cause of these diarrheal infections is ingestion of contaminated food or water. So the solution is to provide safe drinking water and access to toilets or latrines to people who don't have them. So why in 2023 is this still a problem? Well, one of the primary barriers to accomplishing this goal is economic. About 10% of the people in the world today live on $1.90 or less, which makes it impossible for individuals to provide their own safe drinking water supplies and sanitary facilities. Whether we recognize it or not, most life decisions involve a consideration of two factors, risk and cost. And typically, the two factors of risk and cost are interrelated and need to be considered at the same time. Most decisions related to environmental issues involve characterizing the risks incurred by people and other living things and evaluating the cost of taking action to eliminate the risk, as well as the cost of doing nothing. So how do we characterize risk? Well, risk is the probability that a condition or action will lead to an injury, damage, or loss. Well, probability is a mathematical statement about how likely it is that something will actually happen. And probability is often stated in terms of like the probability of developing a particular illness is 1 in 10,000, or the likelihood of winning the lottery is 1 in 5 million. It's important to make a distinction also between probability and possibility. When we say something's possible, we're just saying that it could occur. It's a very inexact term. Probability specifically defines in mathematical terms how likely it is that a possible event will happen. Some other vocabulary terms you need to be familiar with are consequences. The consequences of a bad outcome resulting from accepting a risk can range from minor to catastrophic. And the economic cost of dealing with bad outcomes is one of the consequences of accepting a risk. All right, so how do we assess risk? Well, environmental risk assessment uses facts and assumptions to estimate the probability of harm to people or the environment from a particular environmental factors or conditions. Assessing the risk of a particular activity, chemical, technology, or policy to humans is difficult, and several sources of information and tools are used to help clarify risk. If a situation is well known, scientists can use statistics based on past experience to estimate risks. For example, the risk of miners developing black lung disease from coal dust in mines is well established, and people can be informed of the risks involved and of actions they can take to reduce the risk. So, assessing risk. We have a person here who's trying to decide whether or not to use this chemical ammonia. So she's thinking about what are her chances of having a negative outcome? What are the consequences if she does have a negative outcome? And what might the cost of those negative consequences be? And she's going to use all this information to make a decision. Risk management is a decision-making process that involves using the risk of assessment and selecting actions to minimize or eliminate risk. And it's included as part of all good environmental management systems within business and industry. A risk management plan includes evaluating the scientific information that's available about the risks. It also includes deciding how much risk is acceptable, deciding which risks should be given highest priority, where the greatest benefit would be realized by spending limited funds, and deciding how the plan will be enforced and monitored. From a risk management standpoint, the deciding question ultimately is, what degree of risk is acceptable? In general, we're not talking about a zero risk standard, but rather the concept of negligible risk. So, how is risk perceived? There are often discrepancies between scientific and public perceptions of environmental risk. Numerous studies have shown that environmental hazards truly affecting health status in the country are not necessarily those receiving the highest attention, which is interesting. What is the proper role of government and other organizations in the management of risk? Should the government focus available resources and technology where they can have the greatest tangible impact on human and ecological well-being? Or should the government focus resources on the problems about which the public is most upset? They're not always the same, right? All right, so let's think a little bit more about how risk is perceived. We've got a graph here on the x-axis. We have different environmental hazards that are listed, and then how their risk is perceived. The blue cylinders are by like the general public, and the gold cylinders are how risk assessors rank these or perceive these hazards. And then on the y-axis, we have the rank of risk from lowest going up to highest. So if you look at this graph, there are some examples where the general public and risk assessors feel very differently about how risky certain hazards are. Like hazardous waste sites. The general public perceives hazardous waste sites as being highly risky, whereas risk assessors rank them actually quite low. Let's see if there's some others where there's a big discrepancy. Sewage, radiation, heavy metals. These things are all perceived to be more risky by the public than they are by risk assessors. And there's some other examples that go in the other direction, like loss of wetlands, invasive species, global warming, loss of wildlife habitat, and population growth. These are things that risk assessors find to be highly risky, but the general public is much less concerned about them. And then there's some that are right on, like genetically modified organisms and pesticides. The general public and risk assessors are on the same page about those. It's an interesting graph. So perception and mathematical reality can be very different things. All right, let's shift to environmental economics. So economics is the study of how people choose to use resources to produce goods and services, and how these goods and services are distributed to the public. Economics is an allocation process that determines the purposes to which resources are put. And environmental problems are often primarily economic ones. So economists look at resources as the available supply of something that can be used. And classically, there are three kinds of resources. There's labor, like human resources, capital, like technology and knowledge, and land or natural resources. Economists look at resources as the available supply of something that can be used. So let's talk a little more about these. Renewable resources are formed or regenerated by natural processes. Some examples of these are things like soil, vegetation, animals, air, and water. Non-renewable resources, in contrast, are not replaced by natural processes, or the rate of replacement is so slow that it's ineffective. For example, iron ore, fossil fuels, and mountainous landscapes are non-renewable resources on human timescales. All right, some more vocab terms here you'll need to know. Supply is the amount of a good or service that people are willing to sell at a given price. Demand is the amount that consumers are willing and able to buy at a given price. And the relationship between supply and demand is often illustrated with a supply and demand curve. Price reflects the strength of the demand for and the availability of the commodity. So when demand is greater than the supply, the price rises, right? When demand is less than a supply, the price lowers. If I were you, I'd pause this video right now and write down some examples in your notes. So something where demand is greater than the supply and the price goes up, like toilet paper in 2020, right? Supply went down because everybody bought it up and demand was high, so toilet paper got more expensive. An example in the other direction where demand went down and supply was up, so the price got lower. This could even be toilet paper prices in 2023, right? There's plenty of supply. The demand is less than the supply that we have available, so the price has dropped relative to what we paid in 2020. All right, and here's a supply and demand graph. So supply and demand for old corrugated cardboard. On the x-axis, we have the supply of old corrugated cardboard. And on the y-axis, we have dollars per ton of old corrugated cardboard, so the price. As supply increases, this line here, we see that price also increases, right? So if we look here as a position of low demand, when demand is low, this is the price with low demand, so maybe $57 per ton. But when demand is high, the price can be double that, right? All right, so let's look at a graph of supply and demand over time. This is a graph of the average price for old corrugated cardboard over time. So on the x-axis, we have the year from 2005 to 2019, and the y-axis is the dollars per ton. And you can see a general trend that as time goes on, the price for old corrugated cardboard has gone up, with some dips in there, but the general pattern is a linear one. All right, so let's talk a little bit more about supply and demand. Things like the cost of land, weather, machinery, fuel and chemicals, and the price of food, these three factors all contribute to the price of food, right? Now, assigning a value to natural resources. We assign a value to natural resources based on our perception of their relative scarcity. If a natural resource has always been rare, it's expensive. If the supply is very large and the demand is low, the resource is often perceived to be free. And even renewable resources can be overexploited. Ecosystem services are a tangible source of economic wealth, and the challenge lies in disentangling complex natural systems into more discrete commodity units so that natural scientists and economists can use the same terms to describe ecological changes in the same way. The economic value of pollination services by honeybees and other animals is estimated to be about $200 billion per year annually worldwide. And this service has been brought into sharp focus by worldwide problems in the survival of domesticated honeybees. So this is a good example of an economic service that's been valuated. In addition to environmental services, there's also environmental costs. Pollution, extinction, depletion, and loss of scenic quality are all examples of environmental costs of resource exploitation. Often environmental costs are difficult to measure since they're not easily converted into monetary values. How do you put a value on giant pandas, right? Or Karner blue butterflies? All right. So deferred costs are those that are ignored or not recognized or whose effects accumulate over time that eventually must be paid. For example, the Colorado River dams provide electric power and irrigation water, but they also lead to the loss of native fish species. External costs are those that are borne by someone other than the individuals who produce or consume a good or service. An example of this is a logging operation removes so many trees from a hillside that runoff from the hillside destroys streams and causes mudslides. The logging operation has transferred a cost to the public, right? There's also opportunity costs. These are costs that occur when a decision precludes other potential uses for a resource. For example, if houses are built in a forested region, the land's possible use as a natural area for hiking or hunting is lost. And probably most environmental costs include external, deferred, and opportunity cost aspects. A good example of this is the use of high sulfur coal. External costs are damage done by acid rain, paid for by the public, and reduced productivity of forests and loss of scenic values. A deferred cost of using high sulfur coal is, over time, an accumulation of acid precipitation has destroyed forests. So it's not something you'd necessarily notice immediately, but over time, it does have real impacts. We've actually lost a lot of faces off of famous limestone statues have been eroded by acid rain. And there's also opportunity costs. The quality of water used to wash coal is degraded, so it's not suitable for other purposes. The economics of pollution. Pollution is any addition of matter or energy that degrades the environment for humans and other organisms. When we think about pollution, however, we usually mean something that people produce in large enough quantities that it interferes with our health or well-being. Pollution costs are private or public expenditures to correct pollution damage once pollution has occurred. And pollution prevention costs are those incurred either in the private sector or by government to prevent either entirely or partially the pollution that would otherwise result from some production or consumption activity. An example is the cost incurred by local government to treat its sewage before releasing it into a river. That's a pollution prevention cost. The philosophy of pollution prevention is that pollution should be prevented or reduced at the source whenever possible. An important aspect of this philosophy is that pollution should not be an external cost paid for by the public, but that the potential pollution cost should be internalized and reflected in the price of the good or service being provided. Cost-benefit analysis. This is a formal process for calculating the costs and benefits of a project or course of action to decide if the benefits are actually greater than the costs. In the United States, the National Environmental Policy Act of 1969 mandates environmental impact statements for major government-supported projects. For example, providing clean water and improved sanitation. In 2012, the World Health Organization published a cost-benefit analysis of providing improved water sources and sanitary facilities to people who do not have them. All right. And you can see that table here. So we've got up top here, these are all benefits, right? They list economic impacts, a place for comments, and economic benefits. And they put everything into dollar amounts, right? Because we're talking about economic cost-benefit analysis here. So they estimate the benefits would be $169.77 billion a year. Now let's look at the cost analysis. They estimate the cost to be about 39 billion a year. So what do you think? Is it worthwhile from a financial aspect to provide universal access to improved water and sanitary facilities? Yeah, if you're just looking at the dollars, it's a no-brainer, right? And of course, there's also moral and ethical implications, right? It's not just about dollars, but this is a useful tool to get people on board and to find money in governmental or company budgets. All right. Concerns about the use of cost-benefit analysis. So some people argue that if the only measure of value is economic, many simple non-economic values such as beauty, quiet, recreational opportunities, or cleanliness will be overlooked or ignored. And different cultures and even different people within a culture may have very different opinions of the value of non-economic resources. One particularly compelling critique of a cost-benefit analysis is that those doing the study must decide which preferences count. That is, which preferences are the most important to even include in the cost-benefit analysis. So keep this in mind. Whenever you see a cost-benefit analysis, you need to think critically about it. Is everything there that should be? Is there something important that's not being valued and included? All right, comparing economic and ecological systems. Many environmental problems are symptoms of an imbalance between socioeconomic systems and the natural world. And how economic and ecological systems differ. Time is a big one. Economic timescales are short, like years to minutes short. Ecological timescales are longer, years, centuries. Location. Economic systems can occur anywhere, whereas ecological systems are specific to their geography, right? Units of measure are different. Economic systems measure in money, but ecological systems measure in physical and biological units, grams of biomass, individuals in a population, genetic diversity, and complexity. Ecological systems involve thousands of kinds of organisms and physical environmental conditions. Economic systems, in contrast, involve many fewer parts. All right, let's talk about common property resource problems, or Hardin's tragedy of the commons. When everybody shares ownership of a resource, there's a tendency to overexploit and misuse that resource. And this problem is inherent in common ownership. It was outlined by biologist Garrett Hardin in the classic essay, The Tragedy of the Commons. The commons were pasture lands in England, provided free by the king to anyone wishing to graze cattle. There are no problems on the commons as long as the number of animals is small in relation to the size of the pasture. However, the optimal individual strategy, so for any one farmer, is to enlarge their personal herd as much as possible, right? All right. The ecosphere is like a large commons. I want to go back and add on to this. So in Hardin's, this example with the commons in England, what ended up happening was each of the individual farmers tried to grow their own herd as much as possible. And if everyone's sharing this one common resource, the pasture land, but they're also trying to take as much of that pasture as possible for their own herds, then eventually the pasture will become decimated and no good to anyone, which is exactly what happened. So we need to have some kind of management, some kind of rules in place that everyone agrees to abide by. All right, the ecosphere itself is a large commons, right? The U.S. and other industrialized nations consume more than their fair share of the resources, right? We harvest too much fish. We put too much pollution into the atmosphere. We let too much garbage slide into the oceans. We we don't steward these common resources effectively. All right, so common ownership of parks and streets. And the tragedy of the commons also operates at an individual scale. So let's talk about some ways that we can prevent a tragedy of the commons. So using economic tools to address environmental issues. A subsidy is a gift from the government to individuals or private enterprise to encourage actions considered important to public interest. Subsidies are useful when they have a clear purpose and are used for short transition periods. When used inappropriately, however, subsidies can lead to economic distortions. For example, it might keep the price of a good or service below the true market value. Think of milk. What's it cost for a gallon of milk at the grocery store today? Like $2.50-ish, less than $3. I have a herd of dairy goats and I milk cows sometimes, and I can tell you it costs me at least $10 a gallon to produce these products. So why is it that the milk at the grocery store is so cheap? Subsidies. And subsidies can also encourage activities that are detrimental to the environment, right? If they're not applied appropriately. Once subsidies become a part of the economic fabric of a country, they're very difficult to eliminate. So can you imagine public response if subsidies for milk were to be removed? And if you went to the grocery store and had to pay $10 or $12 for a gallon of just store brand milk, there would be huge public outcry, right? A lot of families wouldn't buy milk anymore. So it would have big implications for both the farmer and the consumer. All right, market-based instruments. Historically, governments have sought to achieve environmental improvements by establishing regulations with penalties. Governments also use economic tools known as market-based instruments to encourage people to meet environmental goals. And market-based policies allow people and businesses to choose solutions that make sense to them economically. For example, informational programs. These provide consumers with information about the environmental consequence of purchasing decisions. Tradable emissions permits. These give companies the right to emit specified quantities of pollutants like carbon dioxide. Emissions fees and taxes. They make environmentally damaging activity or products more expensive. Deposit refund programs. Place a surcharge on the price of a product that's refunded when the used product is returned. Think of like our pop cans and pop bottles. And performance bonds. Fees that are collected to ensure proper care is taken to protect environmental resources. All right, so let's consider the life cycle of products and extended product responsibility. The life cycle analysis is the process of assessing environmental effects associated with the production, reuse, and disposal of a product over its useful life. Entire useful life here. This process can identify changes in product design and process technology that would reduce the ultimate environmental impact of the product. So look here at this model. We've got some upstream parts of production. So we're first coming up with the ideas. We have to collect the raw materials. We have to make the product. Once the product is made, it needs to be distributed. Consumers use it. And then when they're done, it usually ends up in the garbage, right? Or it gets recycled. But there's some kind of downstream waste management here. So it leaves the consumer. It goes through some type of processing. Maybe recycling, maybe incineration, maybe a landfill, and ultimately it's disposed of. So when we think about the life cycle of a product, we're thinking about this whole process here, from just conceptual thing to when it's done and disposed of. Extended product responsibility is the concept that the producer of a product is responsible for all the negative effects involved in its production, including the ultimate disposal of the product. And the logic is that if manufacturers pay for post-consumer impacts, they will alter the designs in order to reduce waste. Economic and sustainable development is a development that meets present needs without compromising the ability of future generations to meet their own needs. Most definitions refer to the viability of natural resources and ecosystems over time, and to maintenance of human living standards and economic growth. So, in summary, risk is the probability that a condition or action will lead to an injury, damage, or loss. Risk assessment is the use of facts and assumptions to estimate the probability of harm to human health or the environment that may result from exposures to pollutants or toxic agents. And cost-benefit analysis is used to determine whether a policy generates more social benefits than social costs. Criticisms of cost-benefit analysis is based on the question of whether everything has an economic value. Excuse me. There's a strong tendency to overexploit and misuse resources that are shared by all. Economic policies and concepts such as supply and demand and subsidies play important roles in environmental decision-making. And recently, several kinds of market-based approaches have been developed to deal with the economic costs of environmental problems. All right, and finally, sustainable development has been defined as actions that address the needs of the present without compromising the ability of future generations to meet their needs. Sustainable development requires choices based on values. All right, that's it for chapter 3, guys. If you have any questions, write them down, bring them to office hours or lab, and we will talk about them.